Today we are going to look at change of subject of formula. Change of subject of formulae. This is the plural of formula. Some replace E with S and say formulas. It is still acceptable English. We are going to look at the first example here. Make arrow the subject of the formula. Sometimes they will say, make R the subject of the equation. They are referring to the same thing. And this formula is S equal to 2R plus T all over 2R T. Everything here under the square root symbol. Our solution here, the first thing is to remove. Let's write again. S is 2R plus T all over 2R times T, everything under square root. Recall that this S is the same thing as writing 2R plus T all over 2R T, and if I put this in bracket, this is raised to power half. That is the meaning of the square root. Square root means power half. The number raised to power half is the square root of that number. Now, in this case, we want to eliminate the power half. And we can only do that by multiplying both sides by the reciprocal of half. And the reciprocal of half is 2 over 1. So if I am doing that to the right hand side, I must do the same thing to the left hand side. So I multiply this by 2 all over 1. Remember that 2 over 1 is sitting as 2. So we have 2s squared equal to 2R plus your T here all over 2R times your T. Your 2 and 2 here will cancel out. So eventually this will go, this will go. So we are here. You can now cross and multiply. We now have our S squared multiplying 2R, yes, we do that. 2RT is equal to 2R plus T. Don't cancel 2 here and cancel 2 here. That would be a big mistake, because the 2 is not common to both the numerator and denominator in the way it appears there. So you cannot cancel this and cancel that. Next is to collect all the terms that have R. Here we have S squared, that is 2S squared ROT. Bringing your arrow from the right hand side to the left hand side becomes minus 2R, and everything here is equal to T. You bring out the arrow, and this is 2S squared plus T minus 2. In other words, even 2 is also common, so we can actually write this as 2R into S squared T minus 1, and this will be equal to T on the right hand side. Remember, it is arrow, we are making the subject of the formula, so we have 2R is equal to T all over S squared times T minus 1. Then there is a 2 here, so we divide both sides by 2, multiply by half. We now have our R is equal to half times T all over S squared T minus 1. So this becomes the equation, the new equation where you have made R the subject of the formula. So your final answer is half of T all over S squared T minus 1. Example number 2. Express R in terms of P and Q in the following equation. P all over the square root of 2 equal to R all over R plus Q all under square root. Our solution. We have our P all over root 2 equal to R all over r plus q also raised to power half. All we need to do right now is to multiply both sides by the power, the reciprocal of power half. So I will now square this, and then I will also square this. That's the reciprocal of half is 2. So that these 2 and this will cancel, and then we now have to expand this one as p squared, and root 2 squared is equal to 2. And this will leave you with r into r plus q. Because we are making r the subject of the formula, first and foremost, we will cross and multiply. Cross, multiply. And do this. So we have r plus q is multiplying p squared, and then our 2 is multiplying r. Now let's open up the brackets. We have r p squared plus q p squared is equal to 2r. Bring all the r together. So we have here r p squared minus 2r minus 2r, not p, is equal to, we move the other term that does not contain r to the other side. So we are moving it and becomes minus q into p squared. Alright, we can factorize the left hand side because r is common. So we are left with p squared minus 2, and this is equal to minus q p squared. Therefore, your r will be equal to minus q p squared all over p squared minus 2. Remember, we can interchange them and we write them and it's the same thing. So we can even write this as minus p squared q all over p squared minus 2. It's the same thing. I want you to note this. Note this. That your r equal to minus q p squared all over p squared minus 2 can also be written as r equal to minus p squared q all over minus, open a bracket, and we have 2 and then minus p squared. Now, this now simplified because minus, we cancel minus to leave you with p squared times q all over 2 minus p squared. This is also an alternative answer to the other one that we did earlier. So, you know, in most exams, you can always rearrange the answer. So you must learn how to also rearrange your answers and don't get confused. So something like this can come up. If this option is there, you take it. But if it's not there, you can now do what? Manipulate and see that you have the equivalent of that value when there is no other option that corresponds to your solution. Take note of that. Example 3. Make t the subject of the formula. S is equal to ut plus half at squared. Our solution. We will write our s equal to ut plus half at squared. The first thing is to remove the fraction. And to do that, we multiply through by 2, which is the LCD of this fraction here. The LCD means the least common denominator. If we multiply all through by 2, we will now have 2s equal to 2ut plus at squared. Now, you will recognize that this can be written in the standard form because this is a quadratic equation. So we start with our at squared plus 2ut minus 2s equal to 0. We have rearranged this now in the standard form of a quadratic equation. In a quadratic equation, a is the first or the coefficient of the variable that is used. In this case, the variable used is t. So the coefficient of t squared is a, the coefficient of t is 2u, and then this becomes your b, and then the constant term, which is usually c, this is your minus 2s equal to 0. I hope you are able to record that. Based on that, we now take our t to be equal to, this is the general formula for solving a quadratic equation. We cannot solve this by factorization, it's obvious, and we can also solve it by using the method of completing the square. Better is to use the general formula. In this case, we have minus b plus or minus the square root of b squared minus 4ac all over 2a. Identify your b. Your b is your 2u. So this becomes minus 2u plus or minus. We'll now take the square root. Our b is 2u. We square that. Then minus 4. Our a remains as a. And then our c is minus 2s. We'll close that. So, and everything here will be divided by 2, and our a remains the same, a. Now, do not hurriedly cancel 2 and 2 here. We still work on the numerator. So that becomes minus 2 plus or minus. Let's take this out. This is now 4u squared. Minus times minus is plus. 4 times 2 is 8. And a times s. And everything here will be divided by 2a. So this will be equal to your minus 2u plus or minus the square root. If you observe 4u squared and plus 8as, 4 is common, we factorize that. So this is your u squared. And then next is plus 2 of as. 4 is common. So 4 times this is your 4u squared. 4 times this is your 8as. Everything here will be divided by 2 of a. Now, what next? Recall here that minus 2u plus or minus. This now, remember your sum. 4 times this, you can find the square root of this one. So the square root of 4 is 2. Then remaining the square root of this plus 2as. Everything here all over 2a. Beautiful. Look at the numerator. 2 seems to be common. Not seems, it's actually common. So we take out our 2 that is common. You open the bracket. Minus u plus or minus the square root of u squared plus 2as. Close this bracket. Divide everything here by 2a. At this point, you can now cancel 2 and cancel 2. And then you are left with 1 all over a into minus u plus or minus the square root of u squared plus 2as. You close the bracket. You have now made your t the subject of the formula. Example number 4. Find t in terms of k, q, and s if s is equal to 2r into the square root of pi into qt plus k. Solution. Do not attempt to square both sides as it is like this. It will be proper for you to first of all divide both sides by 2r, so s all over 2r is equal to pi into qt plus k all under square root. So at this junction, if I square both sides, I will now have s all over 2r. I will square this side is equal to squaring also this side, which is pi, our pi into qt plus k. The square root symbol has vanished. You know that. Maybe you want me to write it. Okay, let me write it. This and this and this and this will cancel. So we now expand this to give us s squared all over 2 squared is 4 and then r squared is equal to pi into qt plus k. We are to make t the subject of the formula. So let's bring back our pi. So this becomes s squared all over 4 pi r squared What I have done here is to multiply both sides by 1 over pi. If I multiply here by 1 over pi, pi will cancel, and 1 over pi, the pi is already here. This is equal to qt plus k. In this way, I've already brought out openly the qt plus k. All I need to do now is to isolate the qt. Therefore, we have our qt will be equal to our s squared all over 4 pi r squared minus k. I took this to this side. That's why we have it. And qt remains. So qt is equal to that. Now, don't forget our interest is to make t the subject of the formula. So we divide both sides by q. So 1 all over q into your s squared all over 4 pi r squared minus k, and a closing bracket. This can serve as a solution. There can be modification to this solution by way of making 4 pi r squared a common denominator here. And then, of course, like I told you earlier, you will still have the same result, a similar result to this, and both are correct. Example number 5. Make f the subject of the relation t equal to v all over 1 over n plus 1 over g, all under square root. When you look at it, you say, oh, how do I solve this? It's simple. Just be consistent with the principles. The first thing is, let me remove the square root symbol from the right hand side by squaring both sides. So we have t squared is equal to v all over 1 over f plus 1 over g. You cover that now with the principles and simply go straight and write out what you're supposed to have. Now at this junction, it will be proper for me to continue with the t squared, and I want to simplify the denominator, and this becomes fg here, and then we have here g plus f. Simplifying the denominator, and that's what we have. Then of course, this means that t squared is equal to v times fg all over g plus f. Remember, we have to invert it when we are changing to multiplication, division and change to multiplication, and that's why we have it. Then recall that we are making f the subject of the formula. So let's continue. It means that our t squared will be multiplied by g plus f and giving the result vfg. You open this bracket, you have g t squared plus f t squared, and then of course is equal to v, f, and g. You will bring all the terms that contains f together. So we have here our g t squared is equal to v f g. Taking this to the right hand side becomes minus f and then t squared. Alright. So we now factorize the right hand side. We now have g t squared is equal to f is common, remaining vg minus t squared. We close the bracket. From that level, we can now say therefore our f will be equal to your g t squared all over vg minus t squared. And this is what is expected of you as the result of making f the subject of the formula. Example number 6. Make a all over s the subject of the formula s plus a all over s minus a equal to n. Our solution, we have our s plus a all over s minus a equal to n. We'll multiply both sides by s minus a to give us s plus a in the left hand side, and then we have the same s minus a multiplying n on the right hand side. Now we open the bracket on the right hand side to give us ms minus a n. Remember, we are to make A over S, the subject of the formula. In this regard, we have our A plus AN is equal to MS minus S. I have taken minus AM to the left hand side, it becomes plus AM. And while I have taken my S to the right hand side, it becomes minus S. In other words, I have added AM to both sides and subtracted S from both sides to give me this expression. Now we can factorize this as A into 1 plus N, and then we factorize this as S into N minus 1. Now we are making A over S the subject of the formula. So I will divide this side by S. I will also divide this by S. So I now have A all over S into 1 plus M is equal to M minus 1. So since I'm making A over S the subject of the formula, I now have A all over S will now be equal to M minus 1 divided by 1 plus N. And of course we can write it as M minus 1 all over M plus 1. You will have made A all over S the subject of the formula. Example number 7. Make C the subject of the equation. A into B plus C plus 5 all over D minus 2 equal to 0. We are making C the subject of the equation. So the first thing is to take away to our solution. We will have to take away, or rather remove the fraction. There's a fraction here, 5 over D. To multiply all through by D every term. So now say multiply all terms by our D, the denominator. Multiply by D. Okay. Now if we do that, we have D times A into B plus C plus 5 minus 2 times D is equal to 0. We have not cleared the fraction. That's exactly what we have done. Now, we open up the brackets. So this will give us ABD and then plus ACD and then plus 5 minus 2D equal to 0. Recall that we are making C the subject of the formula. So bring every term that has a C together. And the only term there is ACD. And then take the other term to your right hand side. It will be equal to, starting with minus 2D, which becomes 2D, and then minus 5, and then minus AB and D. Alright? So out of this, we bring out the C. To divide both sides by AD, so we have 2D minus 5 minus ABD. Now this is divided by A and D. There are no common terms, so we leave the solution as 2D minus 5 minus ABD all over AD. Please do not say that D will cancel D here or D will cancel D here and A will cancel. Please, no, don't do that because the expression did not call for that. This A is not common to all the terms in the numerator and D is not also common to all the terms in the numerator. Example 8. Express S in terms of M and R if M over root S is equal to R all over root R plus S. Our solution, as we have M all over root S is equal to R all over R plus S under square root. Because it's an equation, we can cross and multiply. So we have M multiplying R plus S, and this is under square root, is equal to R there, also multiplying this. Now that we have this, we can square both sides. So I open the bracket, I will square this. I open the bracket, I will also square this. Please observe carefully. The reason for the square is to remove the square root that is right inside the bracket here. So it means that M is squared and then B's value is also squared, so the root vanishes. So we have arrow plus s. Arrow is squared, so you have arrow squared. And this root is squared, it becomes s. Recall that we are making m and arrow. We are expressing s in terms of m and arrow. That is to say, we are making s the subject of the formula. So open up the bracket, you have m squared times arrow plus m squared times s is equal to arrow squared times s. Now with this one, as usual, you bring all the terms with s together. So we have m squared times arrow is equal to arrow squared of s minus m squared of s. So that your m squared arrow will now become s factorization into arrow squared minus m squared. Therefore, our s will be equal to m squared over arrow all over arrow squared minus m squared. Now, we can still simplify this to become m squared arrow, and then this means arrow minus m, and then we have arrow plus m, as the case may be. And that gives you the solution to the problem. Here are the exercises for this topic we have just discussed. Change of subject of formula. Question number 1. Make s the subject of the formula 1 plus as all over 1 minus as equal to p over q. You have option A, B, C, and D. Question number 2. Make r the subject of the formula s all over r plus a equal to a all over r. The options are A, B, C, and D. The question number 3. If t equal to 2 pi into the square root of L over G, make G the subject of the formula. You have option A, B, C, and D. Question number 4. Make B the subject of the equation s over a minus y over b equal to 1. A, ay all over s minus a. B, y into a minus s over s. C, s minus a over a times y. D, s all over y into a minus s. Here are the answers to the exercise. Question number 1, option B. Question number 2, option D. Question number 3, option D. Question number 4, option A. Here the nugget for the day.